go up to the depth where there is possibility of any foundation, challenging soil. So we want to do it low cost, especially for village areas, rural areas. So RCC is out of question because it will be so expensive. This was something which I own on a tender, and I could not have finished without that project without this kind of technology. And NTPC, I had to go and convince them that it's going to work. So like several years it is there standing. So this is the distribution system which we are showing right now. I'll show the cross section where how exactly the this is the first reactor where feed water is coming, and on the top you will see there are some grids. The first stage when it comes, we trap the solids if at all it comes. Before that, there is a disc filter to eliminate up to 100 micron. Micron level, submicron level, or micron less than 50, it is trapped here. So normally, why in SBT we are taking so much care? Because other technology they don't worry about solids, suspended solids, because anyway it is going as sludge. But here we have found out that unnecessarily increasing work on the top of the reactor by removing the solids. If you design something that maybe 5 years or 2 years, you don't have to look at it. It's going on 3 years. And worst case, there is a membrane below. You want to do some cleaning. On the top, you just scrap it up, then it goes up. So not much work is there. Here at least people can walk on it, top of it. There is no problem. But subsequently, reactor second, and the right hand side, you see the recycle reactor. Here you are not supposed to walk because this water doesn't have any suspended solids, very little suspended. So you can directly feed on this reactor. This is the first reactor. One side is the direct feed, second side is the recycled part. Go to the second reactor, Anand. Reactor 2. Next slide. Now this is reactor 1. No, you have not captured any of the reactor 2 looks exactly like the recycle bed. You have not captured that anyway. So basically, the same water goes to the reactor 2 and recycle reactor of the first reactor. So this doesn't have suspended solids, and you can directly feed on top of it. You can see that entire reactor is foliage. You can't see the soil below. The idea is that the more you have some photosynthesis on the reactor, the more you are able to harvest the inorganic pollutants. Now, that is why in the entire feed side, you could not see too much of plantation. There was few plants because there we are doing some working on top of it. People going, cleaning, maybe even once in a month or twice in a month. So next you go to the cross section, Anand. This is the plan. On the left hand side, there is a primary treatment unit. So when we are given this project, they said primary treatment treated water will given to you. So we planned like that. Subsequently, we realized that there is a parallel STP operating on the other side. After primary treatment, we are supposed to take. After getting the project, we realized that that primary treatment is not working. So at my own cost, on the left hand side, you can see I have installed a primary, that is settling tank and clean chamber, everything. I have set it up on the left hand side. Then it comes here. This filter also is there, part of the assembly in the pump room. After disfiltration 100 micron, it comes to the top of the reactor. So you can see there are two lines. One reactor boundary, there is another boundary, the second boundary. I'll talk about it in the next slide. What is this? You just enlarge one section, Anand, right hand side. See here what we have done, there is you can see there are two walls. The left hand side, the wall is actually a confinement wall. Now suppose what happens, this is a flooded area. It was actually a lot of water used to come. If you start constructing, and it is because there is no RCC, it can wash away the soil when it is flooded and the whole thing will collapse. So what we did, we not only reinforced the soil, but made a confinement wall around it, so that the water, soil will not escape outside.
And which side you are talking about, right hand side or left hand side?
Both sides, you can see there is this outer wall and the inner wall. Inner wall is actually SBT, outer wall is a confinement wall. Because what happens when there is a flood, something comes, we have no control. That area is actually low-lying area. So outside there is outside the boundary there are agriculture fields. A lot of water comes inside. When I started their project, it was actually on a standing water. Then I understood the terrain. Then I said that nothing is going to work because external this thing we cannot change. Even if you do an RCC, below that soil has to be protected. Even if you do RCC wall, suppose there is a flooding. So what I did, there is an invisible concealed drainage system around it. That's not shown here. So green patch you can see on the right hand side. Can you enlarge? So that is allowing all the water which comes to go out, rain water, outside water.
आनंद भाई जरा अनलाज करो ना जब वो बोल रहे हैं तो प्लीज.
हाँ ये जो ड्रेन दिख रहा है ग्रीन कलर का, this is the drainage system. So outside water will come and fall here. You can see how it is much below the reactor surface, maybe 1 meter or so, 0.5 meter. So any water which comes, it will go out and it will not affect the wall. So this is purely confining. That's additional cost which I invested from my side. Make sure that it doesn't collapse. So these are the situation. Most of the places, whether you go to any rural area, nobody is going to give you premium land. So if you plan like that what happens when there's rocky areas, there are technologies available. You have to reinforce the soil. There are special different kind of engineers. They're not normal RCC structural designers. They're called geotechnical engineers. So they provide the design. There are very few experts in this area. So I got hold of one of them to design for me. I've done 3 or 4 plants in the main presentation also where no RCC is used. No RCC.
Okay.
Purely brick. If you want to reduce the cost, you have to change the government guidelines. They should not insist on RCC. I have not been able to successfully in convincing that why you need an RCC, because in one project they're doing RCC, that same DSR rates they put it, and everywhere they copy that as if it is mandatory to have an RCC tank. I find it very difficult to understand and believe that why everywhere RCC has to be used. But they are comfortable. Mostly civil engineers, they decide everything.
So in this you have not used the RCC, but bricks you have used.
Bricks because they provided NTPC has fly ash bricks. That was part of the contract. They provide all bricks.
Okay.
Otherwise, I can go do even membrane. What is that? Earthen embankment.
Okay.
So I can eliminate. I will show one photograph. Some university have done. No brick. Only earthen embankment.
Okay.
This is the future for rural or semi-urban areas where land is slightly not so constrained. It requires little more extra land. As you said, as you see, there is a reactor. Then I have gone ahead and prepared an embankment. That area people in city may not be able to give us.
Yeah.
So that I can understand where there is no land, you have to go for RCC because the wall thickness is so less. And like in industry, we did in apar industry, and I showed the difference in cost. So I went for brick wall, they agreed. 3 meter wall,